Okay, dah start kan?
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. We are from group number 4 for lab section 4, transmission line, no load and matching impedance. Okay, this is our team member. I am Nur Syafiqah Natasha binti Samsudin, and thanks to our instructor, which are technologist Dr. Zikri Abadi Baharudin. Okay, for learning outcome, we have only single learning outcome for this lab, which is at the end of this lab session, we should identify the characteristic parameters of line operation under no load during matching and during symmetric. Okay, for equipment and component, we have only 5 component over here. Then synopsis and theory, we refer to the videos that our instructor sent at the YouTube, in the YouTube. Okay, and for the procedure, there are 2 experiments that we need to complete. This is circuit for figure 1. Okay, 4.1 experiment procedure. We need to set up the no load circuit as illustrated in figure 1. Firstly, we disconnect the resistive load to study operating response under no load for both line lengths, which are 300 and 150 kilometer. We set the voltage to the nominal value, which is 380 voltage at the beginning of the line. The outer conductors are designed L1, L2, and L3. The neutral conductor N. We measure the variables indicated in the table. The power always comprise 3 phase value. And then we record all the result in this table. We have table 1. This is table 1. We record for line length at 150 kilometers. For table number 2, we record the line length for 300 kilometers. This is all the wait a minute, and then I pass.
Okay, my name is Nur Asma Salsabila. In this calculation to determine the voltage rise at the line's open end. It is best to use the voltage measure there to calculate the voltage at the line start. The calculation shown next apply according to figure 1.5. This calculation is continue from above calculation. Next. This is electrical schematic diagram transmission line module 150 km in no load condition. This is electrical schematic diagram transmission line module 300 km in no load condition. For the question based on the data tabulated in table 1 and table 2, why the result of line voltage at sending and receiving end little bit different in case 150 km, but obviously different in the case of 300 km. In 2 cases, the reactive power is negative. It means that load is leading power factor load. For leading power factor load, the voltage regulation is negative. It means the receiving end voltage will be more than the sending end voltage. That's why all receiving end voltage are greater than the starting end in the given case. For the second question, compare the measurement result with the calculated value, then make your summary based on comparative analysis. From two tables on comparison, voltage drop more in second table on 300 kilometer line and current also more in 300 kilometer line. Active power is 0 in 150 kilometer and very less equal to 1 watt. Reactive power requirement is higher in 300 kilometer line than 150 kilometer line. Now, next presenter.
Okay, I'm Mark Maxtin and I will present about the matching under load. Okay, to study the response during matching, the resistive load is decreased from its maximum value until the attainment of the power level specific in the table below. In this case, both line length, the nominal voltage 380 volt is to be set at the start of the line and maintained at the value through readjustment whenever necessary. The variables indicate next up to be measured. Record for the following result and details. Okay. These are the line length of 150 km record table. Okay. Table number 4, which is line length of 300 km and the recorded value of power. Okay, and then this distribution between this range, it is operated state non-matching. The supplied reactive power is now at its minimum value. Theoretically, is 0. This operating point is to be found by slowly changing the load resistance, starting from its maximum value. Measured value during the matching, line length of 150 km and supplied voltage is at 380 volt. Next, for table 5, measured value during matching, line length of 150 km and supply at 380 volt. Okay, these are the active power of the load and the others power. Okay, we continue in our table, which is at 300 km and recorded all the active power, line voltage and reactive power. Okay, next. Okay, here I will tell about a question, which is P, which is in the reactive power. Okay, using the calculated the corresponding load resistance, which is also represent the characteristic in impedance. Okay, plot the line resistance for the line length of 150 km. R is equal to the impedance of 2,440 ohm. 244 ohms. Okay. For the line length of 300 km, we calculate in about 245 ohms. Okay, next. Here, we're about to show in our schematic diagram, which is connected from the transmission and receiving section, which is connected onto the resistive load for 150 kilometers. Okay, next. Okay. In this also, we also connected with the resistive load condition, and it is at a transmission line model of 300 km. Alright, next. In here, based on the data tabulated in table 3 and 4, we have discussed the features of the result based on the following arguments. Okay, first, the argument said that we are suggest the result in medium transmission line. This is 150 km and the 300 km. Okay, which is the Ferranti effect observed in the long transmission line is more, and at low load condition, the receiving end voltage is higher, which is at higher loads, the drop in voltage at the receiving end is observed more in long transmission line. Voltage regulated is poor in long transmission line compared to medium. Right, next. Well, okay. In the data tabulated in table 3 and 4 also discuss about the compare the measurement result in medium transmission line and long transmission line, which is also can affected by the Ferranti dominant in long transmission line. Okay, as load increases, the reactive power drawn by the line increases, which is reactive power generated by the line, and the rating of the shunt capacitors and resistors to be used for long transmission line will be higher than medium transmission line. Therefore, the long transmission line in the line conductance to be decreased by increasing geometrical means of distance of the terminator, so the voltage drop in the line. The reactive power drawn by the line decrease at the higher load condition. All right, next. What is the relationship of those results in table 5 and 6 corresponding to the matching impedance issue? When the length increased from 150 to 300 km, the impedance also increased, right, which may derive from the formula of P equal to V square of R. Okay. Compared to the measured result in medium transmission line and long transmission line, when the length is increased from 150 km to 300 km, the voltage and active power will decrease, but the reactive power will increase. The current also remain the same. Right, next. Alright, okay, we will continue with our next presenter.
Hello, my name is Muhammad bin Abdul Rahman. So here I will talk about the conclusion from the experiment. So the conclusion is, we know that the characteristic parameter of line operating under no load during matching and while symmetry may be identified. We disconnect the resistive load we may identify. We disconnect the resistive load in no load circuit to investigate the operational response. In this instance, the line voltage at the sending and receiving end is somewhat different in the case of 150 km transmission line, which is medium transmission line, but significantly different in event of 300 km transmission line, which is long transmission line. In the case of both line length, the nominal voltage 380 volt must be established at the beginning of the line and maintained via adjustment as needed. So this is the conclusion for the experiment. So for the question from video lab 4, I can see my lecturer asked, why at the receiving end of transmission line current at power is 0? So from the video, we can see active power, reactive power, and apparent power is equal to 0. So this is the cause of Ferranti effect happen on an energized long transmission line, which is we consider for a long transmission line is more than 80 km, which may cause the voltage increase in the receiving end of an electrical transmission line when it is operated in a no load or low load, which define current receiving will be equal to 0 in no load condition. This effect occur as capacitance and inductance are the main parameter of the line and due to the charging current of the line. Okay, next. Okay, that's all from our group. We are from group 4, class BEI S1/2. Thank you for watching.